Good evening, everyone. My name is Harsh, and we'll be mostly today talking about the DevOps. So, first of all, thank you so much, everyone, for joining this session on our weekends. I know it's a Sunday, but still, thanks for your enthusiasm to learn something new about the trending technology, the DevOps, and now if we see in a current market, the DevOps role and job is kind of a trending. So in today's session, will be mostly talking about the DevOps. What is DevOps? Why actually it's required? What it can add the values to the business uh, if you adopt the DevOps culture into your teams, your business, and everything. A part of that will be also talking about if you are working as a tester, IT operations in team, and if you are looking forward to switching your roles to DevOps, then we'll be also discussing those things. What skills are required, what tools are required, technologies, and all those things that part of the DevOps practices. So again, my name is Harsh, and I'm working as a DevOps engineer at Oracle. And if we see the today's agenda, then here is the things we'll be looking into all those things about the how traditional IT was working, how the DevOps can help the things, the use case, life cycle, workflow principles, who are the DevOps engineer, what actually the DevOps engineer can add to your business and everything. So that their roles, responsibility, and all those things. So, if we now further talk about the evolution of computing, in previous process or in a traditional way, previously the development process was something like waterfall. Uh, then we further move to the agile, and then we can further move to the DevOps. And if we talk about the application architecture, it was mostly in old times it was fully monolithic. So what basically monolithic mean is like you have the single code, or you have a one big application that having all the code about all the business logic, also their operations and everything. So it is the single package or a kind of single things. And this monolithic application people used to deploy on a physical servers, and they are managing this tedious task on the data center physical servers and everything. So it is hard to manage and do the releases for the monolithic applications. Then people further adopted the agile development process. So in agile, generally they do the regular scrums meetings, they do the weekly sprints and everything, uh, to increase and make the development process of better on a regular basis, so they can release the feature or add the feature to application with a better way. And people also started adopting the n-tier architecture of application. So by n-tier generally means is it depends on the tier you have in your application. You might be having the 2-tier application, you might be having the 3-tier application. So it depends on your tier. It goes from like 1 to 3 to n tier, whatever the tiers of applications you are running. You might be having the web tier, then you might have the middle tier, data tier, and that goes on with your application. Then further, the IT industry adopted the virtual server. So everyone might have used the virtual servers, or in another word we can say VMs. So everyone might have deployed on a VMs and everything. So hosting everything. Now the current trending part is the DevOps or microservices, container, and the cloud. So it is the last line that mentioned over here. So today we'll be mostly talking about the DevOps part, microservices, little bit about the containers, cloud, adoption, and all those things. So if we move further, what actually DevOps looks like. So this is the in a simple picture. If I would like to explain you how the DevOps looks like, then it is the combination of development, the QA process, and also a little bit about operations. So it is I can say a merge of all those things. It have the some sort of development things, the testing part, QA part, and the operations part. Now, if we see the typical software release process, the traditional way, how previously people used to, kind of deploy the applications and everything, then it's more like you have some sort of idea. Then you gather the requirement to create the application. Then you code that application. You test that feature and everything. You build the packages and you deploy it to server. In this specific typical process, there were mostly two team might be part of this process. One is the developer team and the another one is operation team. So the only issue was that the developer team is more worried about their code. Uh, they are just writing their code, uh, just simply testing it on a local things and everything, and after that they are just giving that code to operation team. They don't care much about the where code gonna run, what will be the server's requirement and all those things. So developers more worried about their code, while the operations teams don't have much idea about how the code is written, how much that code will be able to handle the traffic or all those things. So operations teams more worried about the stability of application. So on the operations teams also, they will be manually doing everything. They might be installing the tools on server, they might be manually deploying the application on a server, and manually configure the firewall rules, and tons of manual work for the operation team. So when the developer is giving their code to operation team with the wiki or a doc or anything, then it might could create the issue for the operation team. They might do not get the idea how to deploy the application, how to run the application properly, what is the requirement of application. So it is the one kind of problem in a it was there in a traditional process, the how people used to deploy. Suppose somehow your first version is deployed, developers worked with operation team, they help, and after 1 2 3 days your application is deployed on a server. But now again, once it is up and running, the end user is using your application, but now you need some sort of improvement. You have some new features to add in your application or release new features, everything. You might need to optimize your uh, software with a kind of little bit server tweak, code tweak, and all those things. If there is some bug, the development team might have to resolve that. Operations team might have to handle the bug, or they might have to take down the site or run the different versions, the older versions and everything. So it is the kind of a continuous process. If you generally see, once your application is deployed onto server, then it is not the kind of the done of work. You might be continuously updating your application, you might be adding the new features to your application. So it is the continuous process of releasing the new feature, resolving the bug, optimizing the performance, and it is the continuous task. But if you are doing the manually, or if the development teams is doing so much of manual work, the operations team is doing the so much of manual work, then the whole release process of releasing your new feature, it gonna take so much of time. At least for your team might be able to release the process in 2 3 days. It might take that longer if documentation is not proper, and all those issues might developer and operations team face. So it is the continuous process of adding the improvement and adding the features and everything. So as I said, in a simple word, if I say what is the DevOps generally mean, is like resolving the roadblocks that could come into the continuous delivery process. So if you see over here, you might, do the continuous planning, you do the code, then you do the building, testing, package, release, operate, and monitor. So, continuous delivery, in another word, we can say. And it is all about the continuous process into the DevOps. So as a DevOps, if you are a DevOps engineer, if you are working as a DevOps role, then your job is to make the process streamline, and you generally resolve the issue and make process very speedy and convenient. So business can roll out their features very quickly, and end user or whatever users are using your application can use those application in a speedy way. You can manage your application on a server in the speedy way. So that is all about what is the DevOps. It's more about the streamlining the process, more about resolving the blocks that is coming into the business to do the frequent release, do the continuous update into the application, and all those things. So we'll be, handling the, if anyone have any question or anything, then maybe we'll be handling the question at a right. So feel free to raise your hand at the right, or just drop your question into chat. So we'll be handling all those. I will be answering everything at the last. Now, if we further see, what challenges DevOps try to solve, then as I told about the, two teams, the developer teams and operations teams. So developer cannot deploy their code into the server because they don't have idea about how to configure the server, what will be the server requirement, or how to create the server, how to patch vulnerable, and all those things. So developers cannot, do the deployment. While on the operations side, they don't have idea about the application. It's like operations team or IT operations or anyone network engineer might don't have idea about the little bit coding or what is the feature of application, like how application actually running, what is the database required for that application, the connection string configuration, and so much of stuff. So operation team don't care about that. What they care about, what is the application currently running, it could be the stable, and they just care about as much as possible release the version with the stability. While on other side, developer do not consider where their application gonna deploy. They just run the code, they just write the code, and they don't care much, worried about the server size and all those things. They just care about writing the feature. While on operation side, as I said, if deployment guide is not proper, then it is very hard to deploy the release for operation team. They do not have any idea like what need to be deployed. And also, as I said, developer try to deliver and give the feature as soon as possible. So DevOps try to resolve all those issues. There is no proper documentation, or developers just worried about their code. Operations have the issue about all those things. There is no checklist. Also, need any type of checklist, like this needs to be done before deploying anything. Now, if we further look into the challenges with the tester team. So generally, what issues tester might could face with the continuous, uh, continuous release process. Suppose you have written any feature, you have written the code, and test team might come into the picture. You build the package, the developer give them for the testing and everything, but tester have to verify the two things. They have to verify the end-to-end system, whether it is not breaking the existing running system, and they also have to verify the new feature that is going to get deployed in a future to production system. So for tester also it is the so much of manual work. Each time they have to verify end-to-end system, they have to verify whatever new changes are coming and all those things. So it is for tester also manual job and everything, and it might could delay the release if you have some tight deadline or and all those things. And if testers are not able to verify your application, then I don't think anyone gonna deploy to directly production without proper testing. Then the same things goes for the security team. If you are writing the code, writing the features, then the security wise also there should be some checklists that need to be checked. Suppose any type of user permission, or security team might need to check the vulnerability before deploying the application, or it is not affecting to system security. So on operation side also they might need to check the stability of system. If adding the new feature could might break the system or application on a production. So on the security side also it is the same thing. They might have to do the manual job, yeah, checking the different stops manually, and checking on the security issues manually. Then the same thing, it might could delay the release of the application, and the team might could miss the deadline, and end user won't be able to get the release on the time. So as I said, there is the tons of manual work for operations also. So executing the command on a server side, if they configuring the server, uh, they might be preparing some development environment, the variables, the user permissions, and all those things. It is also the same thing for operations team, the tons of manual job. And if anything goes wrong, then that whole environment is gone, and to recover that whole environment it would be hard for the operations team, because they don't have idea who run or what they executed. If the whole team is working on single server and someone run the wrong command, then the server is down, and it would be hard to do the tracing, like who executed that specific command, and it might could lead to the uh, downtime of your application. So there could be also bugs and knowledge sharing issue if someone is manually running the command, and if that person is leaving the organization after a month or anything, then there could be chances he might miss to share the details with another guy or everything. So that is also the one issue. So whatever issue I mentioned, or whatever the manual process we talk about, that generally get handled by the DevOps, or it is the kind of culture that resolves this issue and make it little bit easy for a business to uh, release the application frequently. Now how the DevOps different from the traditional IT. So if you can see the developments over here, they are managing the UAT environment, the development environment, doing the testing, and after that they are just giving their code to operations team, just deploy it on the production. And operations team just take that code and they try to deploy it, while on the DevOps side operations teams have idea about all the kind of available environments. They have idea about the dev environment, UAT environment. They are also managing the prod environment. And if there is any business requirement comes, it just goes into the continuous delivery process. The bugs, task, or any issues managed by the service desk. So it is the a little bit different, and operations teams have more visibility and more idea about the process, how the things are working on dev, how the things are working on the staging and production and all those things. So general, if we see the DevOps principle, so it is more about you continuously, 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 do the automation of existing system. You create the culture in your company. uh, if you have the multiple teams, you regularly meet the teams across the departments and everything. So it is more about the creating the culture into the company, so that developers and operations team can meet together. They meet, interact, and share the details. So it is more about continuously doing the automation. So whatever the manual job is there, ideally, as a DevOps person or as a DevOps engineer, their role is to do the automation and reduce the manual work as much as possible and streamline the process. So you automate, you also measure the impact, like whether it is adding some values to business, or like it is reducing the time to do the release and all those things. You share the details with the other teams, and you interact, get the feedback, and again you create some culture, you follow the process and all those things. And it is continuously improving the process and streamlining the process. And this is the general life cycle of DevOps. So what generally goes is something like, first you do the coding, then you build it, you test it, you planned. Sorry, the plan is over here. You do the release. From release, you do the deploy to production. You operate it, you continuously monitor it, and you do the planning. If any changes are required or anything, then you do the planning, and you again start writing the code. So it is the continuous infinite process of improving on a daily basis or on a frequent ways. So it is about the life cycle of DevOps. Now, what generally adopting the DevOps culture into the business can add the value. So suppose if currently any business is uh, running on the traditional IT practices, they might be facing the issue with a slow release of application, and they might have the issue with collaboration and everything. They cannot scale their applications. So the benefit of DevOps is more like it can really add the speed to your development process. If in your organization multiple teams are working, then it can add the speed into your development process. You can do the fast releases, improve collaboration, deliveries, and everything of application is very speed. You can also add the manage and get the idea about security, if there is any vulnerability or security issues are there into the application. So it's more like DevOps is kind of mentality. You ship the small increment quickly and safely. So it is more about creating the culture into organization. Now generally organizations are using the agile process for the development. And I have also seen some of organization mix up the DevOps and agile. So DevOps also goes along with the agile process. So what generally, if any product based company is there, they have some product backlog. They might be having the sprint backlogs. They run the sprint on a 2 weeks basis. And then there is user stories, bugs, and all those issues. So it is a kind of example of agile development. And the DevOps goes the same way. You do the sprint release, you do the CI/CD integration. So we'll be also looking into the term CI/CD and all those things. As soon as developer commit the code into the repo, that goes to CI server, and the things that deploy to the dev server, further it goes to over here into the continuous testing, then it goes to the continuous delivery and all those things. So we'll be talking about all the terms of DevOps in depth. I will be also showing once more one or two demos about how the actual tools and technologies work. So DevOps really can go along the agile process, and it can also streamline your process to do the frequent releases. And I have seen once the company have, adopted the DevOps into their culture, they, started doing the releases on a weekly basis. On a Friday, they are doing, adding the new feature. The developers are creating, adding the new features into code on a weekly basis, instead of, planning out the monthly and all those things. So it is add a very speedy delivery options and reliability and stability to systems also. Now, how generally, DevOps help is more like it is the combination of three things. It is the combination of a little bit culture into your teams. It is also a little bit about the practices you have to follow, the best practices that is suggested by DevOps, and it is more about using the tools also. So there are some tools and technology that you can follow, so which can help you and create the process properly into your organization. So the definition of DevOps goes something like anything that creates the process of releasing software fast with the high quality. You can say it like, you know, DevOps, or you are adopting the culture. The main part of DevOps was something like, developers and operations team, work together very often. They meet, they share the ideas and all those things. So it is more about, culture, practices, and the tools. We'll be talking about the tools further into the slides, but here is about the, practices and how you can create the culture or philosophies. Now, when it's come to the, adopting the culture or planning out, any practices or planning out any tools and everything, then it might, create the issue on the each of organization. So if you are a DevOps engineer, or if you are looking forward to switch to DevOps engineer from the, you are a tester or anyone network engineer or anything, you might, see this issue go very often into the market. So let's say there is a 3 4 organization. Some are running the Node.js, some are running the Java. So everyone is following their own practices. So it is not like, suppose any organization have adopted the DevOps, then they are using the same tools, they are using the same practices, or the same, regular interval they are doing. So they might be using the different tools, different technologies, and all those things. So some companies suggesting let's do this way, some companies suggesting this way. So in each of organization they have the different process. So as a engineer, you might be having the idea across all those available tools, all those, available technologies and everything. So you can very easily get adjusted into that environment. So when it's come to the DevOps, it is so much of things you might be having the idea around. So as I said, it could be the different across the environment. If you are in a medium scale environment, then as a DevOps engineer, you might be doing everything. You might be doing the, automation, you writing everything, you are creating the servers, you are doing the release, you are building the code, you are testing the code, you are looking into the security part. So the DevOps engineer in a medium scale company or a small scale company, you are a whole and soul kind of thing. The developer gives you the code and you are doing everything. You are managing the dev environment, staging environment, production environment, databases, writing the automation, monitoring the systems, everything. So it depends on, companies to company, and it differs also. So as I said, DevOps as a, it could be the separate roles, depends on environment, it got changed. So in some of in some of organization it could possible, uh, developers are doing some of DevOps job. In some of our organization it is possible the operation team is doing the DevOps job. They might be, setting up the tools and everything. And that is also possible in some of organizations. They have the special role of DevOps. So the whole DevOps team is there, which is handling or helping out the developers, helping out the operations teams, and they are helping out across the organization, everyone. So it is possible the developer might be doing the same thing, operation team might be doing the same thing, or there is a specific person, DevOps engineer there who is doing everything. So if there is specific role, then it might DevOps engineer, as I said, it will he will be managing everything. If we see the DevOps word as in terms of tool, like when I say that DevOps, and you don't want to just get your head around philosophy or practices or anything, and you just want to get idea, like as a DevOps what I need to know or what is actually need or skills I might be having, then I can call myself or work as a DevOps engineer. Then I have mentioned the set of tools over here. So as a DevOps engineer, these are some of the tools and technology you might be knowing. So some of, if you are a tester or anything, then you might have idea about the source code management. You might have used the Git. Then the next things comes into the cloud. Further, if your application is running on the containers, then you will be having the idea about the containers. Then the central part of DevOps is like a CI/CD. The CI/CD is more like you are doing the continuous integration and continuous deployment. I will be talking about the CI/CD further, but as a DevOps role or as a DevOps engineer, you must be focusing on the CI/CD part, because it is the central thing that is actually connecting the both dots of developer and the operation team. So you might be setting up the tools of CI/CD and planning out the releases, uh, mm, major release, minor release, and all those things. So we'll be talking the further. You might be having the idea about some sort of monitoring tools like Prometheus. Then a Datadog is there, so you might be having the idea about those. The further things also comes, people started adopting infrastructure as a code. So it is more like you can create the server with a code. So I will be also showing the demo about infra as a code. uh, Further, now if you are DevOps engineer, you might be having the idea about the package management, because you will be building the code. You will be having the idea about managing the packages and all those things. So if you have use the Java, then you might, having the idea about Maven, maybe Gradle. Then in Python side, you might be having the idea about the PEEP and all those things, and PM for the JavaScripts and everything. So these are set set of tools that need to be known, or you might be having the idea before you switch your career to the DevOps. And I have also mentioned some tools and technologies into the DevOps. So when it's come to the code, you can use the Jira, Git, for Git for the committing the code, Jira for managing the user stories and everything. Or you might be using the Bitbucket repo and all those things. For building, you might be having the Maven and other stuffs. For the testing, you can use the Selenium, JUnit. For the release, Jenkins is one of the tools that IT industry is adopted very well. So mostly Jenkins is a open source famous tool for the same. Then further, if we look into the monitoring part over here, then you have the Datadog, the Splunk is also there. Into the operation part or the operate side, you have the Kubernetes, Ansible, Chef. So Ansible is a more kind of configuration management, while the Kubernetes is about the container orchestration. We'll be also talking about this, further things. Ansible is about the configuration management, as I said. Then as a DevOps engineer, you might be creating the servers. So you might have to use the cloud for leveraging the servers. Or if you are not on cloud, then you might be having the idea about the uh, on-prem technology or a data center if you are running the on-prem servers. So AWS is there as the cloud, or you can use the container Docker. Then this is the DCOS, the data center operating system, and all those things. These tools and technology change with the organization, as I said. Not all the organizations are following the same tools and technology or the same process, because as their code base change, their technologies change, their requirement change, and everything. So it is not like the 2 3 tools and you can switch to any of the company. You might have to go join the new company, and you might need to learn the new tools or technology as a DevOps engineer. So maybe I think we can take like a little bit of break, and I think uh, Guvi team maybe handle further for 10 minutes, and they will explain about the learning experts and everything, and will be just start our uh, this slides further about the DevOps role. We'll be giving about the demos and everything. We'll be talking about further. As of now, till now, we discuss about what DevOps try to resolve the issue, or what generally DevOps practices rules. Uh, we we talk about the life cycle. We talk about the uh, you know definition and everything, what challenges DevOps resolves and everything. So now we more going to talk about the role of DevOps engineer into organization. So if we talk about the DevOps engineer role, then who are the DevOps engineer into the organization? So they're mostly responsible for the creating the CI/CD management. They will be managing the kind of a release cycle of application, writing the specifications of servers, suggesting the specification, any change, if anything required. They will be also creating the documentation, the processes, and all those things. That they will be also writing the like automation scripts. So having some idea about the scripting language or little bit the coding would be also beneficial. If you are planning to be the DevOps engineer, then they will be also doing the continuous performance assessment of application which is running into the production, continuously monitoring. Or if you are into the medium scale or a small scale company, then you might be doing the little bit job of SRE. So there is also another role of SRE things, but for in mid organization or small scale organization, you might be looking around the SLI, SLOs, and all those terms that comes under the SRE practices. So, or you might be having some experience. If you are student, then you can start the career having the idea about the necessary tools and technology, the Git, Jenkins, and all the details that Manjunath shared into their slides. You might need the idea about the cloud, the scripting language. You can opt for maybe Python, Go, or anything. You need to have the idea about database, because when you are deploying your application, that application might need the multiple databases. So if you have some website running, it might be the using Elasticsearch, it might be using the MySQL, it might be using some sort of database. Then you might be having the idea, because as a DevOps engineer, you might be setting up those databases on a server, and you share the database details to developers, and they use that databases. So those idea about how that database works, their replication, their backups, and all those things, you might need the idea. So it is the more role of DevOps engineer. Now as we talk about the boundaries, like from where the boundaries of DevOps engineer starts. So it's not like as a DevOps engineer you will be writing the code of application, also you will be doing all the operations and everything. So generally as a DevOps engineer, the roles mostly starts from when the developer commit their code to the Git repository. or whatever, kind of say source code management tool you are using, either SVN or Git. So you might need the idea about how developers are working, their Git flow, what is the branch strategy they are following, and all those things. So generally, DevOps sit over here into the middle between the developers and the operations. So as the operations side, you need idea about the basic Linux commands, CLI, the HTTP, IP, DNS, and all those things, the cloud idea, ISE database, as I mentioned. Uh, you also need the idea about how application working generally, the environment, the connection details, and everything. So here is how the application releases works, and here is the actual part where the DevOps comes into the picture. So it is somewhere middle of development and the operation side. And over here, I mentioned the term CI/CD. So that CI/CD comes over here into the picture, and that is the whole heart, or we can say a center point as a DevOps engineer. And you might be having the good idea or hands-on around the CI/CD part. So, like before we talk about the CI/CD and everything, you might need some idea about the like microservice architecture, as we discuss about the microservice into like a evolution slide, the first slide. So, what generally microservices, it is the kind of architecture of application. If you see the general code or a general architecture of application, is like you have a one code only, you have the multiple file 15, 16 file, and that that files having the whole code about the application or a website. While in a microservices, it is not like that way. In organization, you have the multiple teams. Suppose you have one account team, you have one user team, you have one setting team, you have some you know another team with a different name based on requirement. So each of these teams are mostly focusing on their services. The account service team is only writing the code about account service, while the user service team is only writing about the sign up things, signing things, and all those things. So they only worried about their user service code. The setting team is only writing the code for the setting, and they only worried about their services. Now the microservices talk to each other. So account service might be sending the details to setting service, the setting service might be sending the details to user service. So it is the general architecture of microservices. These services interact with each other, send the data, pass the data. And in microservices, it is possible the account team is using the Java as a programming language, while the user team using the Golang, other team might be using the Python. So there is also a different types of technology each team using. And generally, when we deploy the microservices, mostly microservices get deployed with the container. So container is also the trending technology with the Kubernetes. So Kubernetes is the orchestration platform for the containers. So you might need the idea about container also. So containers and this technology mostly take hype from 2014 around, and people started adopting these microservices and Docker containers and everything from 2014. And from there, the DevOps also goes into the market, and now everything is trending: Kubernetes, Docker, CI/CD, DevOps role, and everything currently in the market. So, as I said, we talk about the microservices here. Also, I would like to mention about the container. So, container is more like you are, building or zipping or creating one package, and you are just zipping to any place, and there is a guarantee it will run. So, you can create the container, or you can create the kind of package or a bundle with any of the technology. If you are running the ASP.NET or Java, Ruby, JavaScripts, or like Hadoop or anything, you can run all those software onto the containers. And you can run the containers on physical servers. You can run the container on virtual machines, on cloud, Windows systems. Also, you can run the container and you can host your application. You can host your websites or whatever is there. You can also even run the databases into the container. So Google is mostly, running everything into the container. They are also running their databases into the container, and they are handling the billions of container, every week. So, as we talk about the central part, we talk about the CI/CD. So we'll be now discussing more about the CI/CD. So what is CI/CD is more like the full form of CI goes like continuous integration, and while the full form of CD is goes with continuous delivery or continuous deployment. Now it is depends in an organization or depends on the DevOps engineer what like they would trying to integrate. They might could use the continuous delivery, or they might could use the continuous deployment. Based on the requirement, you can choose any into the CI/CD. So if we first talk about the continuous integration. So what is continuous integration? Uh, as soon as developer check in their code to repository, if you are have the idea about the GitHub or anything, as soon as they're checking, developers add the code into the source repository, the CI server, if you are using the CI tools like Jenkins or any other tools, then the CI tools runs your checks. So you might be configuring some rules over there on a CI tool. So it first build the code, then it do some test, and it give you back the result. So that process called the continuous integration. So it is kind of automatic there. This CI server, Jenkins, or whatever tool you are running, or whatever tool your organization has chose, it is continuously monitoring this source repository. As soon as anyone commits, developer or you do the changes or anything, it just take out those changes and automatically do the building testing and set the result to you. So it is kind of automated process with the help of tools and technology. So that was about the continuous integration. So as I said about the continuous integration, developer add the things to Git. It run the test cases, build the packages, Java files, and everything, and it says the details. Now, if you are using the containers instead of just simple application, then it might be possible your CI server or Jenkins or any tool you are using, Circle CI or anything, it might be building the containers, and on top of the container images, it might be running the test on those images or container and all those things. And at the last, the container images get pushed to the artifacts repository. So that is also the automatic process. So your code generally get pushed to the source code repository, while the container images get pushed to the artifact repository, or in another word, we can say container registries. So that is also like you can create the automation for the same. If anyone committing the code, this whole steps or all the steps will be automated. I will show you the small demo around how the container get created, images, and how the test runs and everything of CI. Now the next part comes is about continuous deployment. So generally in continuous deployment, what happens is about we talk about the CI, right? As soon as code deployed, we do the testing and everything. Result got written to us, and further is continuous deployment. So continuous deployment is more like when your code is built, your package is ready, you automatically build it to development environment like test environment, staging environment, and production environment, and it is the automatic. So as soon as I have committed, the application will get deployed to the production one by one, goes to development, staging, and production, and end user will be automatically started using the new release or a new feature. So uh, that is what about the continuous deployment. The only difference between the continuous deployment and the continuous delivery is only this part. In continuous deployment, it is the automated part. While with the continuous delivery, you might have to manually approve the request. Till then, your package, your build, or your tool will be waiting, and it won't deploy the code to the production server. So once you approve, then and then in continuous delivery, your code will get deployed to the production server. Otherwise, it won't be. It will be till staging only. Still, it's more on to up to you how you are configuring. But this is the main point, of, where it differs from the uh, continuous delivery and the deployment. So as I said about the continuous deployment, you here till here it is the part of CI. You do the run test, create the images and everything, push to repository, and you directly deploy to the server. It is not like just a simple process over here. You just build it and you just directly push the release or your code to the server. There is also some extra things you can, generally people add as a DevOps engineer. You get the email notification if anything goes wrong. Suppose your Jenkins or CI tool is building the container or building the image or building the code and it got failed, because it is not a guarantee. Like developers are always checking everything and after that verifying they are pushing their code. Sometimes it might be possible some developer is having some mistake and the build is failing, it is not getting created properly. So whenever build fail, we might be getting the Slack notification or email notifications. So with CI tools, it is also extra things that need to be integrated, or you you want them to get notified what is happening. If your application is having some streaming, video streaming, images streaming and everything, then from CI/CD or automatically you might want these specific images automatically get pushed to any bucket or any storage or any file system from where you can just deliver via CDN. So if your application is using the CDN, so that steps is also there. If any build is failing, then what CI server has to do to just mark it as a failed, or it has to retry 1 2 3 times to build the image. So that is also you can configure into the tools and everything. So it is kind of core concept of CI/CD, how the CI and CD works. So we talk about the CI part and the CD part. Now I would also like to show you one quick demo of CI/CD. We talk about integration and the deployment part. So for that, I have one code over here. I think my screen is visible to everyone. So it is the simple Node.js code. Let me build, grab few other tabs. Yeah. So over here you can see the code. It is nothing much, just printing the hello words and version 1.0, and it will be printing the host name. Now, if you over here, I have set up one CI/CD trigger. So anytime I will be updating this specific file or I will be committing anything into this Git repository, this trigger will get auto run. So what is the event or rule I have mentioned is like a push to any specific branch and it will run the trigger. And over here you can see the connection. I have done the connection of this repository and it is continuously monitoring. It's in enable state. So if we see the history over here, as of now, there is no build is running. Let me just change the status to running. So as of now, there is no, CI/CD or any process is running. Now, suppose I update the code. I'm just changing the version to 1.0.1, and I'm just committing my code to the Git repository. And as soon as I have committed the things, this trigger should be start running. See, you can see the new things. Now it is building the things. We can check the logs also. So here are the logs, what is happening, how the build process is, running and everything. So it is downloading the necessary files for my Node.js code, since it is the Node.js. And I have also mention all the steps over here into the YAML file. This is how generally you configured your things, the CI/CD part. So first it will build the Docker container. For that we need to give a Docker file as an input. So I have also created that into this repository. Then we push this specific Docker image to registry as I showed you into the slides. And then further it is doing the continuous deployment. So it will deploy to the Google Cloud, and it will be the continuous deployment. So we can wait over here till this gets successful. So it is downloading the necessary SDK files and everything that need to do the deployments and everything. And while over here in the service side, over here, there is no services running. So I have not deployed any type of version or anything. It is just a blank. So soon there will be the one service which will get deployed from our CI server, or I can say a CI tool. So you can, write down all the necessary rules or configuration over here. Suppose I'm not, checking any notifications over here. If anything goes wrong, then I won't be getting the notification part. So you can add the notifications over here, or if you are more into the security things, you can add the, static code analysis. You can add the security scannings over here on CI side. So whenever code get pushed, the security and all those scans get happened over here on the CI side. And here, if we just refresh, then our service should get deployed. So if you see over here, there is one service got deployed. So this is the Hello Rajkot service you can see. And I'm just allowing everyone can hit the URL. So service is in ready state. We got one URL also. So this is the example of continuous deployment. And if we hit it, we are getting the output of application. So we have the message, we have the version that we updated, and the host name on which it is running. So it was the kind of small demo about CI/CD and how it's work. And it is not always this type of simple configuration. If you have the larger system, multiple services running, then in each of, for each of service, you might be having the different configuration. For some, it could be Java, Python, and all those different requirements based on what teams are running. So that was about the, quick demo of CI/CD. Now we check the continuous deployment, and we also talk about the continuous delivery. So as I said, the only difference is the manual approval over here into the continuous delivery. Everything got built and everything in the demo we saw, it was deployment, so it got deployed. Otherwise, it should ask us first and look for the approval. So over here, it is the same thing. We build the container, push it and everything, then it wait for the approval, and then only it get deployed to the server. And this is the difference between the delivery and the deployment. As I said, the manual and the auto part, other all things are integration builds, and it is the same. Now, as a DevOps engineer, you also need to have the idea about the cloud, because that is the main part where you will be running the application in today's world. Like, it is not a necessary, some companies that might be running on on-prem data center. So you need an idea about the on-prem data center also. So it is more depends on the organization's requirement. When it's come to the cloud, you can choose one of the cloud like AWS, Oracle, GCP, or anything. And with cloud, there is the multiple services available. So you might be having the idea about the general services part, having the idea about the VPC networking, how the networking work, best practices about the cloud and everything. So it is also necessary to deploy the server. Otherwise, what happened? Like, you have idea about few tools, but don't have idea about cloud, then you won't be able to deploy anything. So you need the details about cloud also. Now, as a as I said, you also need the concept of cloud. You having the idea about the clustering, networking, the backup strategy, the server backups and everything. You will be using the disk backups and everything, load balancing and tons of stops, security monitoring onto the cloud and everything. And also, cloud offers a range of services. So you having the idea about how to save a cost, the idea across the different services, or like suppose uh, in my perspective, one service is better on Google, the another service that I like is better on Oracle. So you might have to make a decision. Well, you will be running your application and you might have to share your ideas to your team, or you might have to convince to CEO or whatever, your manager, your authority, and you have to share them and let them know that this is the difference between this cloud, this is the cost issue, this is the all of things that you might be doing. Having the idea across the different cloud also helpful. Now, suppose any organization is running the multi-cloud or hybrid cloud, then you need the idea about those networking part. uh, when we talk about the hybrid cloud, then it is more like your application is uh, running on the private data center and also running on AWS. So some of requests coming to AWS is from there it is going to your private cloud or a private data center, and from there response comes back. So you have to take care about the security part also in hybrid cloud, multi-cloud, and all those things. So cloud is also one of the main thing you should be having the idea. So this was about the hybrid cloud and multi-cloud. So this is how it's happened. Like suppose your workload is running, you are using the two things: private cloud, uh, public cloud, and the traditional IT, and it goes with the networking part and everything. In multi-cloud, you use the two public clouds. So you might be using the Oracle cloud, IBM cloud, or AWS with GCP clouds, and you run the workload over here. So if one whole cloud goes down, you still have the one backup running. Or it is also possible you have database on AWS side, while your services, the code and everything running on Oracle side. So from Oracle, your request goes to the database running on AWS. So it is more about the architecting, networking, and all those things on the cloud. This is the main thing. Personally, I think now, as a trending part, all the organizations are running the containers and Kubernetes. So as a DevOps engineer, you will be having the idea about the Kubernetes, and Kubernetes have the also different uh, concept. So Kubernetes have their own networking. There is the types of services, how Kubernetes, you can set up the availability, volumes, and if you have requirement of running the database on Kubernetes, managing the containers, load balancing, and all those things. So Kubernetes is also the main thing you can learn and trending technology in today's market. So it is also necessary skill to have as a DevOps engineer. There is also one term called infrastructure as a code. So that is also the necessary things. What mean infrastructure as a code is, you have the three environment requirement. You have development environment, you have staging environment, and you have a production environment. So if someone suggests you like create a three server for me, same to same server, then you won't be doing the manual job, right? You create a one server, the second one, the third one, and then you configured everything on each one of them. Then it is the too much of time, and it might could take a 1 day or 2 day for you to create the three server with the requirement and everything. So generally, infrastructure as a code means you have written a one code. Whatever code we write, uh, as a Python or as a shell script or anything, you have one code written, you apply that code or you run that code, and at the end, you will be having the server up and ready. So I would also like to show you one small example of that demo, like how you can run the code and create the server for the same. So let me just open console first. And I will quickly create the VM for this demo. So as of now, you can see I'm not running any VM or no server is running currently over here. Now I have a code already written over here. You can see I have used a tool, or I can say the scripting called the Terraform. So Terraform is the kind of language with that you can write the code for creating the servers and everything. So over here, I will be creating one server with the Debian 10 operating system, and I will be also installing the Nginx inside that server, which is the proxy. And generally every people use that Nginx. Then I will be creating one virtual machine with it will be in which zone the machine type will be what and everything. And I have also added, if you notice over here, I'm getting all this value from the variables. So what you can do is something like you can create a 3 variable files, one for development, one for the staging, and one for production. And all 3 files having the different variables. So if you look over here, these are the variables I have defined. The machine type is F1 micro, the name of my server will be web server. So what you can do is you can change these variables in 3 different files, and you can just pass that file as an argument, and you can run your command. So you will be having the same 3 servers with a one code only. So this is also helpful if anything goes to wrong into your environment. Suppose your server is not running, or some have run the wrong command and everything. You can just make the server in few minutes the same to same replica. Only things matters is you having the code of that server what you are running. So for example, I'm just checking the plan. So this is the command for Terraform to check the plan. So it will be showing what resources it will be creating into this cloud. So over here it will be planning to add one resources. So we'll be creating one resources. So I'm just allowing it. Sorry, I'm just applying it. I want to create one server, and it is asking me, are you sure you are planning to create? I'm just giving the yes, and soon you can notice over here one server will be up and running. So see over here the server is up and running, and here is my code running. So this is the kind of example of infrastructure as a code. I'm managing my servers and everything with the code. And as I written into my code, I need the IP address of that server. I can show you the code also, the output. As an output, I need IP address. So the code written also need the IP address. So this is the web server IP address. So once this status is up and running, we can hit the IP address and we can see the output. Looks like it is ready and running. And now if we hit the IP address, we got the output of Nginx, and we can also do some sort of automation to configure our application and everything with the as a code infrastructure. So we can also destroy this server. So once that run, now we don't need it. We can just run the destroy, and it will just remove our server. So Terraform destroy, and it will ask for final confirmation. We have give the yes, and that server will be gone soon. So it is stopped, and if we try to access, it won't be available. So that was the demo of infrastructure as a code. Uh, uh, as we see the demo, and here as I showed, you have the one code only, but you can pass the variables into that, and you can create the 3 type of different environment, and you don't have to do the manual job. You don't have to go over there and each of machine or each of server, and you have to do the installation of Nginx and all those things. With a single code, you can do as many servers you want. Now also the part comes with the DevOps engineer is monitoring part. So you might need the monitoring idea. So when you create the server, the monitoring is necessary. If CPU going up, then you might need to do the scaling, or you might need to get a notification if it is running on 100% or your website is down. So with monitoring, you having the idea about tools like Datadog, Prometheus, and all those things, that is also necessary. Now, if I just conclude whatever we have seen, or like watch and everything, demos and everything, I have also list down the tools or by the category wise. So as a DevOps engineer, you can learn this one tools, and you can just switch out your roles and careers, and you can move ahead with the career of DevOps engineer. So first things, you need the idea about the development concepts. You might be having the little bit idea about how code is working, the database requirement, the networking requirement, and all those things. Then you need the CI/CD idea, CI/CD tools like Jenkins. You have the idea about operating system, Linux basis, and everything. Have the again idea about little bit security side, networking side, IP, DNS protocols, and all those things. Have idea at least of one cloud provider, either AWS, Oracle, GCP, or anything. The scripting is also required because you might be writing the Groovy scripts or automation with the Golang or Python, anything. So scripting is also a little bit necessary. The monitoring tools, then container is also like trending, and as of now, all the uh, organizations are mostly running the containers only. So mostly they ask for the containers and the container orchestration tool, which is Kubernetes, the widely used, and mostly all of organizations are on Kubernetes only. So that is also necessary. The version control is also required. So Git is there, or SVN, or anything based on the organization. And as the infrastructure code, widely used is Terraform, that I showed you the demo of Terraform, but there is also another available like Pulumi and all those things. So at least as of now, with the Terraform is very good to move ahead. And as I mentioned about the SRE also, so SRE also comes into the picture with DevOps, but it is the kind of little bit similar things only. But yeah, depends on organization, it comes into the picture. There is a minor, difference between these only, but personally, I think both are friends only. The DevOps and SRE are friends. There is no much difference. SRE more focus on the system availability, reliability, and everything, while the DevOps more focus on the speeding up the development part, creating the automation, and whatever demo that we see. Once we update our code, it should get deployed to the server. So that is what DevOps mostly focus on. The necessary, operations. Developer need your help, the tools and everything, all those things. So SRE mostly works with the operation team. The DevOps mostly work with the product development team. So DevOps might be helping out the developers if developer, stuck anywhere. They need some tools. They need tool setup. They, developer needs some sort of automation and everything. So DevOps mostly works over there. And sorry, SRE mostly also focuses on the operation side. So as I talk about, uh, these are some of the service layer commitments, and some of the, um, I can say, KPIs, SLI, SLOs, and everything that SRE look for. So this when we look for cloud, they talk about 99.99 availability and everything. So that comes under these parameters.